Good morning, good afternoon, ladies and gentlemen. Today we are going to extend what we started before spring break and work on with using trigonometry to find angle measures. This is lesson 8.5. Once we have completed the lesson, you are asked to complete homework 5 from your packet. So before spring break, we used trig ratios in order to find missing side lengths. Today we are going to use trig ratios in order to find missing angle measures. We want to make sure that our calculator is in degree mode. If you're using one of mine, it should already be in that mode. So if you know the sine, cosine, or tangent ratio of an angle, you can use the inverse of that ratio, sine -1, cosine -1, tangent -1, which stand for inverse sine, inverse cosine, inverse tangent, to find the measure of the angle. Real quick, it might do us a good thing to review what is sine, cosine, and tangent. There were 9 letters that we talked about before break, which spelled out SOHCAHTOA. Quickly to review, that was based upon this triangle. If I look at angle A, side BC is the opposite, side AC is the adjacent, and side AB, because it's across from the 90, is the hypotenuse. So the sine of angle A is equal to the opposite over the hypotenuse. The cosine of angle A is equal to the adjacent over the hypotenuse. And the tangent of angle A is equal to the opposite over the adjacent. Using this information and using our great friend SOHCAHTOA, we can determine either missing sides or missing angles. So, on questions 1 through 6, which I'm going to work on the odds, we are simply looking for missing angles. We are going to use the same formula, the same SOHCAHTOA that we've used before to solve the problem. So the first thing that I ask you to identify is what are the sides that I'm given. So the first thing, hypotenuse is always across from the 90, so 24 here is my hypotenuse. Across from the angle is the opposite, so 15 is the opposite side. So what do I know? I know if I have opposite and hypotenuse that I'm going to use the sine of the angle equals opposite divided by hypotenuse. So whenever I fill in the measurements that I know, the sine of x is equal to 15 over 24. Now, your question is, well, how do I get rid of sine? And so if I look on my calculator above the sine key, do you see that it says sine to the -1 power? I hope that you do. To get there, we're going to press second and the sine key and then plug in our fraction. So what it looks like on paper is that x equals the inverse sine of 15 divided by 24. I plug that into my calculator, and I should come out with x is 38.7, and since this is an angle, I label it with degrees. Let's try another. Example 3. First thing I'm going to do is identify my sides. So across from the x is the opposite side. The other side is the adjacent because it helps to form the 90 degrees. So if I'm dealing with opposite and adjacent, I know that I'm talking about tangent. The tangent of the angle is the opposite divided by the adjacent. Or the tangent of x is equal to 20 over 37. I want to move tangent to the other side, so I take the inverse of tangent. And if I plug that into my calculator by pressing second tangent and plugging in the fraction 20 divided by 37, I should get that x is 28.4 degrees. Example 5. Again, I label my pieces. The 41 has to be the hypotenuse because it's across from the 90. The x across from it is the opposite, so 40 is the opposite. If I'm dealing with opposite and hypotenuse, I'm dealing with cosine. Sine. So sine of the angle is equal to opposite over hypotenuse. So the sine of x is equal to 40 over 41. I move sine to the other side by taking the inverse. And if I plug that into my calculator by pressing second and the sine key and then 40 divided by 41, I get that x is 77.3 degrees. Following these first 6, there are actually a set of mixed problems. So let's look at those mixed problems just to review, and also we can take it a step further by having to use the trig ratios multiple times in each problem or in one problem. So example 7, this time I'm given the angle and I'm looking for a side. From the angle, across from it is the opposite side. Helping to form the 90 degrees is the adjacent side. So I see that here I'm going to use the tangent formula. So tangent of 39 is equal to 11 divided by x. And if I remember correctly from right before spring break, when the x is in the denominator, I just switch the x and the tangent 39. So x is actually equal to 11 divided by tangent 39. If I plug that into my calculator, I get that x is equal to 13.6. I'm going to keep moving. Example 9. This side again, I'm looking for a side length. So I'm going to identify what I have based upon that 51-degree angle. Across from 51 is the opposite side. Helping to form the 90 is the adjacent side. So I'm going to use tangent again. So the tangent of 51 is equal to 8 divided by x. If I swap the x and the tangent 51, I get x is equal to 8 divided by tangent 51. So that means that x is equal to 6.5. Example 11. This time I go back to what I started with today, looking for an angle. So I'm going to first identify the pieces I have. I have the hypotenuse and I have the adjacent. I do not have the opposite because I don't have anything on the side across from x. So this time I'm going to use cosine. Cosine of the angle is adjacent divided by hypotenuse. So the cosine of x is equal to 14 divided by 22. I'm going to take the inverse cosine of the opposite side to move it. So I press second and the cosine key, 14 divided by 22, and I get that x is 50.5 degrees. Example 13. Again, I'm looking for the angle, so I'm going to identify what I have. I have the hypotenuse. I do not have anything on that opposite side. So the other piece that I have has to be the adjacent. So this is again going to use cosine. So the cosine of the angle is adjacent divided by hypotenuse, which means the cosine of x is equal to 31 over 36. To move the cosine, I take the inverse, which gives me x equals 30.6 degrees. Whenever I move into problem 15, this time I'm going to have multiple pieces, and so I start thinking in my head, what are my steps going to be? I think to myself, I want to first find DF, which is the base of that top triangle, and then I want to use DF to help me to find DE, which is what they are looking for. So DF and that triangle, I'm going to notate everything in red. DE and everything in the bottom triangle, I'm going to notate everything in blue. So if I'm looking for DF, first thing I do is I identify that across from 61 is the opposite side and the 24 is the adjacent side. Since I have opposite and adjacent, I'm going to use tangent. So the tangent of the angle is equal to opposite divided by adjacent, or the tangent of 61 is equal to DF divided by 24. To get DF on one side by itself, I multiply both sides by 24. So DF is equal to 24 tangent 61. And if I plug that straight into my calculator, I get the DF is equal to 43.3. Now that I know DF, I want to base everything on that bottom triangle and the 19-degree angle. So across from the 19-degree angle is DE, which is going to now be my opposite. The original opposite is going to become the adjacent because it helps form the 90. First thing I'm going to do, opposite and adjacent is again tangent. So tangent of the angle is opposite divided by adjacent, or the tangent of 19 degrees is equal to DE divided by 43.3. So DE is equal to 43.3 times the tangent of 19 degrees. And if I plug that straight into my calculator, I get that DE is equal to 14.9. Last problem we're going to look at is a word problem. First thing that I say to do is to draw a picture. So I have a ladder leaning against a wall, making an angle of 75 degrees with the ground. That means the ladder and the ground meet at 75 degrees. If the foot of the ladder is 6 feet from the base of the wall, what is the length of the ladder? So my picture looks like a triangle. The 75 degrees is in that lower corner where the ladder meets the ground. I point to my opposite side just so that I remember there's my opposite. I have 6 feet from the base of the wall out to the foot of the ladder. So this is my adjacent side. The other side that I'm missing is that hypotenuse, which is going to be the ladder, and it is X feet long. So if I am dealing with adjacent and hypotenuse, I'm dealing with cosine. So the cosine of the angle is equal to the adjacent divided by the hypotenuse, which in this case would be the cosine of 75 degrees is equal to 6 divided by x. Since the x is in the denominator, I just switch the cosine 75 and x. And then if I plug that into my calculator, I get that x has to be 23.2 feet long. Guys, if you have any questions, be sure you either email me or you can ask Mrs. Barnhart or Mrs. Lewis or Mrs. Smith for that matter. They should all be able to help you. Please feel free to email me. I will respond as I can. Have a great day.